Welcome to the breakout session, Meet the Innovators. This session is about the focus on basic and biomedical science, clinical medicine, and we are delighted to have a couple of awardees willing to share about their experience with the projects they are working on. So before we start, let me just introduce briefly myself. So my name is Ryan L. Young, and I'm from the University of Hong Kong, and I'm also one of the Catalyst awardees, focusing on metformin and its relationship with healthy longevity using genetics. So let me just talk a bit about the housekeeping rules. So each speaker will have about 7 to 10 minutes to talk about their projects. And after each speaker finishes the speech, then I will start to invite questions from the floor. And then afterwards, then we'll move on to the other speakers. And if we have time afterwards, then we can do an overall discussion talking about different things that the speakers or other people who are joining this session to discuss further and see how we can learn from each other based on the experience that we have. Okay, so right. So before I start, if you would like to share your affiliation or your names, just feel free to type on the chat box. If you're willing to do so. Okay, so right, so let me now move on to the first speaker. So the first speaker is Dr. Gonzalo Jorquera. So Gonzalo, the floor is yours.
Thank you very much. Thank you very much for this opportunity. Well, my name is Gonzalo Jorquera. I'm a biochemist. I have a PhD in biomedical sciences. Now I work as an assistant professor at the University of Valparaíso in Chile. And I'm a 2021 Catalyst awardee by the National Agency of Research and Innovation from Chile. And I want to tell you a little bit about our project. We are very interested in trying to understand sarcopenia. Sarcopenia is a very common disease in older adults, and sarcopenia is affecting the skeletal muscle. In people with sarcopenia, there is a decrease in muscle mass and strength, and this can be very complicated because it could be a very debilitating disease and actually affects the autonomy of other adults and the ability to perform routinary activities can be very altered for them. So actually now there is no pharmacological treatment for sarcopenia. So in our project, we wanted to understand if the communication between gut microbiota and skeletal muscle can be an opportunity for the treatment of sarcopenia in older patients. That is because we know that in young individuals, there is a wide diversity of microbes in the intestines and a wide representation of different kind of bacteria. So we know that this diversity is good for health in young people, and actually with exercise this diversity increase. And when we get old, the diversity of gut microbiota diminish, and the representation of different kind of bacteria is altered in old individuals in a process that is known as dysbiosis. So in our project, we wanted to know if we do intestinal microbiota transplantation from young and trained individuals to all individuals can have a positive effects in skeletal muscle function in the context of sarcopenia. So we are working in a preclinical project. So our model is mice. So in our mice, we have a young and trained mice, and from then we obtain the sample for doing the intestinal microbiota transplantation. And we work with all mice, and all mice is an 18-month old mouse. So in them, we perform the transplantation. So this is a very innovative idea, because the relationship between the gut microbiota and skeletal muscle is a recent field of research. So we think that there can be it can be an important communication between intestines and skeletal muscle. So in our main results, we have found that after the intestinal microbiota transplantation, all mice improve their muscle function. So that is a very good result for us, because it shows that there is a relationship between gut microbiota and the diversity of gut microbiota in all individuals and the function of skeletal muscle. We perform a series of tests in the mice related to strength, endurance, mobility. So we have seen a positive effect of this transplantation. What we would want to do in the future is understanding which are the mechanisms behind this communication between the gut microbiota and skeletal muscle, the biological processes behind this crosstalk, and also we want to move to work with human patients. This intestinal microbiota transplantation is a medical procedure that is performed nowadays in the context of the chronic diarrhea caused by Clostridium difficile. But in the future, this treatment can be used for other diseases. In human patients, now the intestinal microbiota transplantation is done by colonoscopy, and recently it can be done by capsules with the microbiota inside. So that is a very easy way to perform the procedure. So we are thinking in the future that this can be a way to improve the muscle function in older adults. Thank you very much.
Thank you very much, Gonzalo. Okay, any questions from the floor? If you have any questions, you can just unmute yourself. You can ask the questions directly.
Hey, Gonzalo, that was really cool stuff. You can see the transformative nature of what the possibilities are. Something you mentioned was that exercise provides a stimulus that can change your microbiota. What actually is that stimulus, and how does it work?
Well, as I told you, the field, I mean, is new. I mean, there are a lot of new papers coming every day. And for example, it is known that if we compare the gut microbiota between a person with a very active life with a sedentary person, the diversity of microbiota is higher in a person with a active life, a person that perform exercise daily, etc. And the other thing that the general diversity is increased, the other thing is that the representation of bacteria is different. For example, we have in our intestines a type of bacteria that is capable of producing short chain fatty acids. And these molecules can have very positive effects in our body. So And for example, there are other kind of bacteria that can produce, for example, a molecule known as LPS that can produce inflammatory effects in our body. So, for example, associated to exercise, we found that the percentage of bacteria producing these short chain fatty acids that are good for health are overrepresented. Meanwhile, the bacteria producing LPS and inflammatory molecules are down-represented. So this could be possible mechanisms why exercise could be a good stimulus for improving our gut microbiota.
Okay, any other questions from the floor?
Hi, Gonzalo. If you you appear to know some candidate molecules that are beneficial from the gut microbiota, would it be possible to directly introduce those chemicals to the elderly person or older mice to try to recapture the same effect?
Yes, I mean that is a good possibility to try to isolate which molecules are good for health and for skeletal muscle function. But apparently, one thing that is important in the context of the microbial community living in our intestine is the interaction among them. So probably we can, of course, identify one product that could be good for example, skeletal muscle function, but probably the bacterial community interaction can be or can have I don't know, more effects. So we think that maybe the transplantation of a group of bacteria can be better than the administration of just one compound or some compounds.